SAT math tricks. This first one is all about speed. Don't solve the entire problem unless you have to. So in a multiple choice test, you can eliminate answers as you solve the problem. You don't always need to solve the entire problem. Now, of course, sometimes you will have to solve the entire problem and the answer choice won't become clear until it's all done, but other times you can just solve part of it and get the correct answer. So let's take this problem for example. If y is equal to x cubed plus 2x plus 5, and z is equal to x squared plus 7x plus 1, what is 2y plus z in terms of x? Well, we already have y and z in terms of x. So if we need 2y, then we can take our equation for y and multiply it by 2. So that would be 2 times x cubed plus 2x plus 5. And then we add that to our z. And we only need one z, so that's going to be x squared plus 7x plus 1. And now this is just a lot of simple arithmetic. This isn't really a hard problem. It's just combining like terms, multiplying, but it is time consuming. So let's see if we can speed it up. Well, if you look at our answer choices, you can see our first term here is an x cubed. So let's try to solve for an x cubed. We only have 1 here, and that is being multiplied by 2. So our first term is going to be 2x cubed. So we can immediately just eliminate this answer choice here. So we know it has to be B, C, or D. Now if we look at B, C, and D, we can see that our last term is unique in each of them. So if we can solve for our last term, which should be simpler than solving for any of the middle terms, then we can get our answer choice. So our last term, we see it's a constant, and we have 2 constants here. We have 5 and 1. But this 5 is being multiplied by 2, so that's actually going to be a 10. And then we add 1, so that's going to be 11. And so if we go back to our answer choices, you can see that answer choice C has 11 as its last term and 2x cubed as its first term, so that is our answer. And we didn't even have to solve for any of the middle terms. I mean, we could, but solving for the second term here, you can see 2 of them are x squared, so that would not have helped us. But we could have solved for this third term instead of the last term, because they're all unique as well, but it's a lot easier to solve for a constant than to deal with variables. Now this next tip isn't so much about speed, but more Now this next tip isn't so much about speed as it is about interpreting the problem and thinking about it in a way that you can understand it and get to the answer. So sometimes when you have a problem where you need to find an equation for something, it can be easier to just plug in a number instead of trying to work it with the variables and solve it like that. Make up numbers and then plug them in. So our question is, a 300-room hotel collects $75 per occupied room and does not collect any money for vacant rooms. Which of the following functions best represents how many dollars, D, the hotel generates if there are V vacant rooms in the hotel? So this isn't exactly a super hard problem, but instead of using V for vacant rooms, let's actually just make up a number. So using this strategy, instead of saying there are V vacant rooms, let's say there are 60 vacant rooms. So now we can see that the hotel makes $75 per occupied room. So 75, and then let's use X as occupied rooms. So this is how much money the hotel makes. 75 times X. But now we need to find what X is equal to. So X is going to be equal to the occupied rooms, because 75 times occupied rooms is equal to the revenue. So if we need to find the number of occupied rooms to complete our formula, then we need to first start with the total number of rooms. which is going to be 300. So this is the total number of rooms in the hotel, and the total number of occupied rooms is going to be 300, the total, and then we subtract the vacant rooms. So if we get rid of the vacant rooms, then we'll be left with occupied rooms. So x is going to be 300 minus 60. So we have 75, and then if we replace x, this is going to be 300 minus 60. I'm not going to simplify this anymore because we can actually find our formula now. If we just take 60, we know 60 is equal to v. So to find our formula, we just do 75, 300, and then we subtract v. So you can see that our revenue, which is D, is going to be equal to 75 times 300 minus V, and that is going to be answer choice A. So yes, you could have solved this problem probably faster if you just used V in the first place, but if you're having trouble thinking about the problem and you need to look at it from another angle, it's a useful strategy to just make up a number and plug it in. Because instead of thinking of V rooms, you can actually think of an actual number which you can visualize. So this next tip applies to exponential functions. So if you have a problem that deals with exponential growth or exponential decay, or even a quadratic, it's sometimes helpful to plug in 0 or 1. And that means you find your starting point, and then you go 1 forward. So 0 is going to be a starting point, and then 1 would be the next step. So that may seem kind of confusing, but let's actually put it into use with this problem. A minor league hockey team has been collecting ticket sales data over the past year. At a current price of $25 per ticket, an average of 4,000 seats are purchased. They predict that for each $1 increase in ticket price, 100 fewer tickets will be sold. Which of the following functions best models the amount of money that the hockey team expects to collect from ticket sales? Y, based on an X dollars increase in ticket price. So that's a lot of information. So if we use our strategy, and we can see that all of our answer choices, except for D, have 2 x's. We know this is going to be a quadratic. Because if you multiply any of these together, you're going to get an x squared, which would make it a quadratic. So where do we start in this? So if we start at our 0, our starting point, you can see that the starting point is the current price, which here it says is $25. So we're going to start at $25. And then we need to find Y when we have a $25 ticket price. And so we can see that 4,000 seats will be purchased. So we just multiply by 4,000. So our starting point is going to be 25 times 4,000. So now let's plug in 1. Let's go one step forward in our quadratic function and let's see what we'll get. So if we go 1 forward, you can see it's going to have a $1 increase. So Y is going to be 25 plus 1. And then it says 100 fewer tickets will be sold. So if we had 4,000 seats purchased when it was $25, then when it is $26, it's going to be 4,000 and then minus 100. So now we can start to see what our equation is going to look like. So if we go over here to our answer choices, we can see, and again, implying our first tip here, we might not need to solve the entire problem. We can see our answer choice A is 25 plus x times 4,000 minus 100x. You can see if we assume that our x here was 1, this first answer choice actually looks really similar to our y here. And if we assume that we plugged in x for 1, this would actually solve to equal this. So this is looking like our answer choice, but let's let's continue just to make sure we've got it right. Here for answer choice B is 25 minus x. But if you look at our equation for y equals 1, it's 25 plus 1, not 25 minus 1. So this would not work. And then here, we don't even have a 25 in answer choice C. It's just x times 4,000 minus 100x. So that's not going to work because we have to account for our starting ticket price. For answer choice D, this might work, this equation might work for our 0, and that's why we need to plug in 0 and 1. Because if we know that x is 0 here. 25 plus 0 is 25, and then you multiply by 4,000. So if you only did 0, you would think that this could be an answer choice. But we know because we also plugged in 1 that A is going to be our answer choice. So by simply finding a starting point and then moving forward one generation or one step, we were able to solve our problem, and we didn't even have to solve the entire thing.